Okay, so let's get started. All right, so good morning, everyone. Thanks again for joining us. My name is Sarah Husky with 3C Ren. I have started recording this course, which will be posted on 3C Ren's on-demand page. We have Nick Brown and Bobby Hahn with us today to talk about overcoming heat pump installation challenges. But before we get going, I have a few slides to run through. So we just ask that everyone make sure that they're on mute throughout the duration of the course. If you'd like to verbally participate, please raise your hand and we will call on you to unmute yourself. We'll also be monitoring the chat box, so feel free to ask questions there as well. And so a few words about who we are. We are the Tri-County Regional Energy Network, also known as 3C Ren. We're a collaborative partnership between the counties of San Luis Obispo, Santa Barbara, and Ventura, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Ren currently offers 3 programs. Next slide. Thank you. Yeah, thank you. So the Energy Code Connect program serves building professionals by offering trainings and support to make the Energy Code easier to follow. Within the Energy Code Connect program, we offer our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for Title 24, Part 6, and Part 11 questions. And this service is for both residential and non-residential projects. And then our next program is our building performance training, which serves building professionals such as architects, engineers, contractors, and real estate professionals by offering technical and soft skill trainings related to building science principles and high performance buildings. And then we have our home energy savings program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll pass things over to Nick.
Thanks, Sarah. We love working with 3C Ren. They always get a lot of people to show up. There's good interaction and a lot of amazing training topics that you guys are hosting. So keep up the good work. How are you, Bobby?
I'm doing well, Nick.
All right. And I'm pleased to be joined today by Bobby Hahn. Bobby has his boots firmly out in the field, on the ground, in his role as a distributor and sales rep for heat pumps. And Bobby, you've been in heat pumps a long time.
Long time. Yeah, we have a couple of things we're going to discuss today. Is some new terminology about variable capacity heat pumps, but yeah, about 30 years ago, I saw the very first variable capacity heat pump come out, which was a multi-zone mini split, and it's really today has blossomed into a whole industry. So yeah, I've seen the growth of it for the last 28 years. So excited to be here and to talk about it, to pass on my knowledge and Nick as well.
Thanks, Bobby. And I'm coming at this from the energy side of things. I run my own energy consulting firm called Build Smart Group. I'm a certified energy analyst and on the board of KBEC. So this is what I do every day: model projects for energy code compliance, work with clients to make their buildings more energy efficient with lower carbon emissions. And as you all probably know, our state of California is really doubling down and building their climate goals around heat pump adoption and heat pump water heater adoption, electrification of buildings. So this is a key foundational technology that it's imperative we get right. We get these specified right, installed right, and that everyone's pulling in the same direction. Now, in the past, we've used Slido for this presentation. Turns out they're located in Slovenia or something, and I haven't been able to pay to renew my subscription. So instead, let's just treat these as chat prompts as they come up on the screen. And you guys might be able to witness what past attendees have said. So why don't you tell us what you guys do so we can tailor our presentation today to your roles in the industry. Already seen a couple folks from building departments and county public works departments, a researcher. Diana, you'll have to tell us what EcoSnap does. Okay, another county official, great.
Project manager, Kenzie, Ramsey.
Okay, EcoSnap is an easy to install mini split. Wow. Okay, we'll have to give you the mic later on.
Yeah.
All right, good. So when Bobby and I built this presentation to deal specifically with challenges that we hear, and they're the same challenges on field installations, we wanted to start by establishing the reasons that you, in whatever capacity you work, at the building department, running a startup, running an HVAC installation company, whatever, understand the value proposition and why these heat pump systems are so critical. We'll talk about how they work and how they compare to gas furnaces that we've all gotten really used to over the last couple of decades. And then these are the key installation hurdles that come up time and again when we have focus groups and talk to people. Ductwork, how to deal with the existing ductwork. MERV 13 filtration requirements, so the energy code comes into play on a lot of this stuff. Different zone system options and configurations and how to design them. Cold weather, sizing, and then electrical infrastructure. So let's dive into this value proposition piece. Air source heat pumps are growing rapidly, and these are national statistics from AHRI, but I imagine the growth curve is even steeper in California as our energy code and incentives and general regulatory environment has been built around them. So that's reason number one to get involved with heat pumps if you aren't already. Another chart here, this from the Cheers online HERS registry, great place to go for data on adoption of technologies. And you can see that in single family, heat pumps are up above half of all new construction projects. And this was the 2019 code. I imagine it's higher than that now that we're in the 2022 code. Does this surprise anyone? Already more than 50% heat pumps? Now, they're critical foundation for the decarbonization of buildings in California. And our climate is ideal for these. It's different. Even though heat pump adoption rates are strong in places like Maine and Minnesota, they can work there. Boy, in California, even more reason to install heat pumps. We've got a lot of heat in the ambient air year round that these heat pumps can use the compressor cycle to deliver heating and cooling in one system. We eliminate the need for fossil fuels in homes for heating and cooling. And if we do water heating and cooking and clothes drying, you can be all electric and completely cut off that gas line, stop paying that monthly fee to a second utility provider. So they're a key leg of the stool on electrification. Because we know that when we look at a new home built today or an existing home renovated today, and we look at its next 30 years of operation, the carbon emissions of an all-electric home are roughly half that of a home that is built mixed fuel or stays mixed fuel. So you see, it's a huge advantage all electric homes have over mixed fuel homes. And that's why we're here talking about heat pumps and heat pump water heaters being right at the center of California policy. Many jurisdictions that you might work in have all electric reach codes that go beyond that state minimum energy code too. And heat pumps are the only way to comply with those all electric reach codes for space conditioning. This includes places in 3C REN territory like San Luis Obispo and Santa Barbara, also the city of LA. And in the 2022 code cycle, heat pumps were made prescriptive standard in 4 Northern California climate zones, including climate zone 4 that comes down into 3C REN territory. And I think someone said they were from Paso.
Yeah.
Right? Yeah.
Yeah.
But also where heat pumps aren't prescriptive standard, heat pump water heaters are prescriptive standard. And we've got the new language for 2025 that's been drafted. They call the 45-day language. It'll take effect in 2026. And that has heat pumps prescriptive standard statewide. All part of California's strong commitment to climate goals, including SB 32, SB 100, various executive orders that reduce greenhouse gas emissions by 2030 by 40%, in buildings by 40%, incentives like SB 1477, putting a lot of money where the state's mouth is. Other regulatory bodies like CARB, calling for no gas furnace or water heater sales by 2030. And of course, internationally speaking, the Paris Accords that seeks to reduce greenhouse gas emissions worldwide, 26% by 2025. And recently, the federal government passed its own climate provisions like the Defense Production Act and the IRA. Those IRA programs that put money to encourage heat pump adoption should, some of them are already in place, like the tax credits. Others have not yet been rolled out to the states, like the HERA program that promises up to $14,000 in rebates for efficient decarbonization technology purchases for low-income individuals. So brace yourselves, the money's going to get richer. I mentioned earlier the reach codes argument. There's a lot of these jurisdictions. They tend to trend Northern California more than Southern, but you see there's quite a few Southern California and Central California communities now that have said, hey, the state hasn't gone far enough. We want a quicker pace of electrification and decarbonization in our community. So many of these reach codes say you shall build all electric. Note that Berkeley's reach code, which was one of the first and inspired many of the others, was put on hold after legal challenges. So this is an area of local law that continues to evolve. But clearly, those more progressive California communities are trying to find ways to get their economies decarbonized in a more aggressive, accelerated fashion. Anything in chat we need to respond to, Bobby, before you tell us how heat pumps work?
I think we're pretty good.
Okay.
All right, Nick, I'll take over from here for a couple more. All right. So goal number 1, Nick just completed, was the heat pump value to your business. So we're going to take the next step and go into goal number 2, the heat pump's functions and the advantages of the modern heat pump. Heat pumps are much different. When I started in the industry about 30 years ago, much more advanced, which we'll show you today. And we're going to model those versus a traditional gas electric split system. So we're going to show you a video right here of a reversible heat pump.
Tell me if you're getting sound, would you?
Sure.
Yeah?
In the past, conventional electric heat pump systems were known for their poor efficiency and performance in cold weather temperatures. Today, advancements in modern variable speed heat pump and zoning technology gives everyone in the home year-round comfort, even in sub-zero temperatures. Here's how they work. Ultra-efficient variable speed heat pump systems consist of an indoor air handling unit and an outdoor condensing unit. The units are connected via 2 refrigerant lines. Working as a system, the units efficiently transfer the desired cooling or heating energy to each personalized comfort zone. In summer, air conditioning is produced when heat energy from inside a home is absorbed by the system's refrigerant and transferred to the outdoor air. In winter, the refrigerant cycle is reversed and the system extracts heat from the outdoor air and transfers it inside to heat the home. When compared to fossil fuel burning systems, modern variable speed heat pumps provide exceptional heating performance while being a greener, more environmentally friendly option. To achieve this, variable speed inverter compressors use up to 40% less energy than past conventional systems by modifying the compressor speed up or down as needed in order to maintain consistent, comfortable indoor temperatures, a feature conventional systems simply do not have. As an added benefit, some systems allow a single outdoor unit to control up to 8 indoor units for added comfort, efficiency, and styles within a home. Ductless indoor units circulate and filter the air already in your home, resulting in improved air quality with whisper-quiet operation. Today's revolutionary inverter compressor technology is an impressive advancement in residential heating and cooling. These smart systems regulate energy consumption, using only the precise amount of energy needed to keep a home comfortable, saving the homeowner money while reducing our carbon footprint.
Thank you, Nick. So, to recap how these heat pumps work. On the left is the summer season in heat pump operation, where we're expelling the heat from the space that's cooling down the space. On the left-hand side, the heat being rejected to the atmosphere outside. Where you see on the left-hand picture, you see the red discharge, which is going to be the heat, and cooling on the left. Now, how heat pumps also work on the right side is just a mere reversing valve of the refrigerant. So on the right side, utilizing the reversing valve, we're harvesting the ambient heat in the air and pumping that into the space using the same system. So I do know that we mentioned somebody on the chat is a quick install of mini splits, and I'll just elaborate on that. If you see the red and refrigerant lines and blue refrigerant lines, we have a saturated liquid and gas lines. And combined, depending on the insulation size, is about the penetration of a tennis ball, if you can imagine that. So the hole from the inside to the outside is very small. And again, you have very small refrigerant lines going between the indoor and outdoor unit. And basically, that is how a heat pump works. Next slide. Advantages versus standard gas electric split systems. First and foremost, at the very top, no system fossil fuel. Nick mentioned that in an earlier slide to getting away from fossil fuel. No fossil fuels used with heat pumps. Can be powered with rooftop solar, especially on those hot days. Basically, if we're doing that, we're just running DC power to the fan motors and everything else is running off of solar. So very efficient rooftop solar. I'm talking to you from Southern California, and we've had some pretty major gas leaks down here. So we're eliminating any risk of gas because there's no need for gas to be entered into the home using heat pumps. And operational savings costs, especially in numerous municipalities. There are a lot of incentives, as Nick mentioned, and we are going to come back to that towards the end of the presentation. So a lot of cost savings across the board.
Yeah, I'd just add that expectation is that as more and more homeowners transition to all electric, the gas system fixed costs will be borne by a smaller group of ratepayers. And that's what they expect to drive up gas costs in the future relative to electricity costs. Although I think we've all seen both of our bills go up significantly over the last few years. The expectation is that the pace of gas increases is going to be faster than electricity.
Yeah. Okay, another advantage for the modern day heat pump is many of the manufacturers, if not all the manufacturers of mini splits, power their indoor unit from the condensing unit. So there's no need for separate power, much easier installation. The wire gauge is 16 to 18. So it's not very thick wire. And again, you do not need power at the fan coil. And like we talked about in the previous slide and the video, achieve both heating and air conditioning with one system. And here's a big one. The ultra low NOx furnaces. I represent a company Carrier, and ultra low NOx furnaces was a major deal introducing that into the state of California. And a lot of the new designs for the low NOx furnaces are larger than the traditional furnace. So the installation is going to be much harder. You might have to find a bigger spot for the new furnace. So it's much easier to install versus the low NOx furnaces. And if you think about a furnace, typically they're going to be in your attic or your garage, and you're going to have a spider web of ductwork going throughout the home. So it's much easier to install and no exhaust to deal with because it's a heat pump. And in the end, we're meeting our climate goals for California. Next slide, Nick. Okay, if we're going to take away one term, it's going to be, for me, it's going to be variable capacity heat pumps. VCHP, you'll see it mentioned quite a bit in Title 24, especially coming out and going forward, modulating the heat from heating and cooling to match load. I'm not sure if everybody quite understands that, but what that means is basically the compressor, the engine for the condensing unit modulates. So it's variable capacity. In other words, if you compare it to an accelerator in a car, for instance, if you need to go faster, it goes faster. If you step on an accelerator, and if you back off, it backs off. Traditional heat pumps used to be 100% on, meet set point, goes 6 degrees over or under, and then it comes back on again. And then you see your compressor contactor pull in, your lights might dim. So a lot of benefits by having it variable capacity. The SEER, EER, SEER2 is much higher. Both indoor units and outdoor units are extremely quiet. We have applications in very stringent areas like Newport Beach and Beverly Hills, where the dB rating needs to be around 55. Typically, a lot of these side flow or suitcase style condensing units, where it's very narrow and can be mounted very close to the wall, are extremely quiet. Back to the no compressor contactor. So it's a very soft start for the compressor. So all the equipment has a very long lifespan. Again, there's no compressor contactor pulling in, and can be up to 60% more efficient. We had seen when it was just single SEER, we had equipment up to 42 SEER. SEER2, very high ratings. Of course, what we're here for, a lot of us are 2022 and further energy codes. Title 24 Part 6 offers a very attractive compliance credit for heating and cooling, around 10%. Nick, I don't know if there's another compliance credit that gets close to that, possibly heat pump water heaters, but you add those two together, you're in pretty good shape.
Well said.
And the CEC soon will extend the variable capacity heat pump credits to ducted units. Right now, there's a little bit of a caveat between how the code is written. In that, the current code says that they want to have low static units. However, the other side of the code wants MERV 13 filtration with 350 CFM of return air. So that's going to be massaged a little bit, but we'll discuss that a little bit more into the presentation. So I think I'm going to jump back out, Nick. I think you're coming back in here, and I will come back in a little bit.
Yeah, thanks, Bobby. I had a project the other day, a coastal builder. We'd specified heat pumps for this single family custom home, and he came back wanting gas furnace, kind of inertia type situation. And he's like, I can't imagine all that noise outside in winter instead of the whisper quiet operation of a gas furnace. I'm like, are you serious? Have you, because the gas furnaces I grew up aren't quiet, and you've got a penetration through the roof for the flue gases, right? You got to run gas through your building. I'm firmly convinced if California had started with heat pumps, there's no way gas furnaces would make any inroads. You know, 2 systems for heating and cooling instead of 1. But because we started with gas and we got used to that, it's an inertia thing, even though it's a simpler, you know, equally cost effective, if not better, cleaner technology. That's the feeling I get from all my years in the industry talking to people. So that's what this course is trying to do, get us over the hump, you know. All right, so these are the installation hurdles we wanted to focus on today that we hear all the time. Dealing with existing ductwork, what's MERV 13 filtration mean, and what are its implications for the overall system sizing, ductless versus ducted choices. You saw in the video, there's a bunch of different configurations. We want to make sure you know what's out there, because it isn't just the high wall unit or some central ducted heat pump. Got a lot more choices than that. We'll talk about cold weather perception. We'll talk about best practices for sizing them, and what to do when electrical upgrades seem to be needed to fit the heat pump on your panel. So how about you? In chat, what challenges do you guys encounter? Some of the same that we just built this presentation around, or some other ones?
Nick, I run into the top one probably the most is, do we need to redesign the ductwork from
Okay.
existing furnace? That brings up another conversation where these variable capacity heat pumps come in a furnace style configuration. So that's a new one, because most people think about ductless or ducted units or duct free units, but really there's mini splits that have ducts too. So there's all kinds of different new units with different statics that can overcome that. So yeah, you really want to take a look at your ductwork.
Yeah. Okay, redesign, including duct system, aesthetics for the heads of the mini splits. And someone just posted a vote on Slido. Impressive. Yeah, I'd agree. And Bobby, when it came time to take out my gas furnace that I put in this house in 2015, that's what I used. A similar dimension, inverter-driven variable capacity heat pump that was ducted, because that was a simplest way to take the old one out and put a new one in without starting over.
Sure. And a lot of those units have high static capacity, so it can accommodate what was already there.
Right. Any comments on Charles's question on coastal?
Well, we're more concerned not so much about the compressor, but we're concerned about the typical aluminum coil fins. So I've seen equipment, I cover Hawaii as well, and I've seen condensers just rot away next to the ocean, and basically you see the copper left, the compressor and the copper, and all the fins are eaten. So if you do have something, I would say within 3 miles to the ocean, I'd very much consider getting it coated for ocean environments, because you will have basically the performance for the condensing unit. As the aluminum coil gets eaten away, it'll be far less. So it'd be a good idea to, if you're close to the ocean, to get it coated.
And is that available through the manufacturer, Bobby?
That would be through the distributor.
Okay.
So every distributor has probably more than likely going to the top 3 that are in California. A lot of the coating manufacturers and installers are down in Temecula area. So you could talk to your distributor and they could point you in the right direction.
Thank you. So let's start with this. Oh, one more comment. Oh, well,
Yeah,
we're
you
about
can
to
do
dive
that.
into this.
Yeah, I mean, if you have a multi-zone ductless mini split, certainly you can abandon the ductwork that's in the attic, but you might want that attic space back. You don't, that's a free room now. If the equipment comes out of the attic and you have high walls, home running back to a condensing unit for a multi-zone, definitely you can leave it or take it out.
Well, let's talk about that. This study we're referencing on the screen right now was done by NC State, and they found that 25 to 40% of the energy that you're paying for to operate your system is lost in the ductwork.
Yeah,
And,
that's about right. About
right?
30%. Yeah.
It's stunning, these numbers. And these aren't out of date. It's not like we've all of a sudden gotten better at building ductwork or that ductwork lasts longer than it used to. It's just a fact of life that these systems are up where no one's walking around and monitoring and maintaining them. They're not always installed, to the highest standards, and the tape peels and things happen up there. And before too long, you've got leaks. And
Yeah, I
in
mean,
California,
even in the perfect scenario, Nick, yes, you're going to have roughly 30% leakage, but also you're losing energy from the fan coil to one of the furthest register. So you're not gaining all that energy. You're losing quite a bit of conditioned energy by the time it gets to the further down the ductwork. So you got that to add in there as well. So yeah, there's a lot to add up here that we are including, and there's some stuff we could add to it if we wanted to.
right. And when those duct systems are in unconditioned spaces, like we tend to do in California, the vented attic or crawl spaces like shown in this picture here, well, that can be worst case because now you have the potential to introduce and bring in some of that contaminated, not good to breathe air, and your central fan's distributing it all over your house. So yeah, best practice is to replace the ductwork for those reasons. The Energy Code has something to say on this too. They say that for altered duct systems, they need to be brought up to a maximum 10% leakage, and they're tested, right? Our HERS raters are out there day in and day out, putting these duct systems under pressure and measuring the leakage. So my kind of rule of thumb is if you can achieve that 10%, then you're probably all right. If you can't achieve that 10%, then that's probably a sign to go replace that ductwork, and it's certainly a best practice to replace old ductwork. Negatives associated with duct leakage include inefficiency and high energy costs, but also your fan's working more than it needs to. And as Bobby said, that ductwork has been carefully designed to put a certain amount of air in each room to provide for comfort. And as soon as you start having leakage, you have no predictability on where your conditioned air is going, and you're going to have certain rooms at the tail end of the ductwork just not getting enough conditioned air. So the duct leakage allowances, 10% of total air handler airflow, or 7% to outside, or a smoke test. That's what the code requires. But I think as a best practice, I'm here to say beyond 10%, let's replace our ductwork or replace it with a ductless system. Now in past classes, these were the survey results on what percent of the time existing ductwork is being reused. How about you folks here today? feel like at least half the time retrofits are using existing ductwork? Maybe more. Okay, 1 vote for over 75%. All right, well, hopefully what we've just presented helps you guys make that choice to replace ductwork or go ductless.
Yeah, it seems to be pretty consistent. Over 75% are saying just replace air handler and maybe
Mhm.
patch up with the existing ductwork. In fact, Javier just said all the time. So
Yeah, it
yeah,
sounds like we've got a few people in our audience today who are already following best practices. So that's great. Fan watt draw is another Title 24 required test. You know, your air handler fan is going to be measured, and the watts per CFM are regulated to 0.58 watts per CFM for a heat pump, 0.45, even slightly harder target for a gas furnace air handler. So if you have all kinds of duct leakage, you can have a hard time meeting this standard. The other one that Bobby alluded to before when he said 300 in CFM, that's the 350 CFM per ton requirement that we also have to test to with a HERS rater in California. That's another goal you're going to have a hard time meeting with leaky ducts. One other requirement that I want to make sure you're aware of, it's been in the code since 2020, so 4 years already. Your return filter grills need to be equipped with MERV 13 filters. And these typically look like what's pictured here, either 4-inch or 2-inch deep filters, not the 1-inch units that I know I was used to before this code change. So that means higher resistance on your air handling fan. It means that your system needs to be designed from the start to have this much resistance, not just the filter grill, you know, can accommodate this thickness of filter, but everything's been designed with this amount of pressure drop in mind. So there's another reason you're going to have to put in a MERV 13 return filter with your retrofit. And so there's another reason to redesign your ductwork / consider ductless at the time of replacement. So there's, Bobby loves to tout this, the HERS requirements are less when installing a ductless system. And those HERS requirements add a little cost to construction. They certainly add some time and, you know, complication to the process. But I did want to cover why MERV 13 made its way into the code, because I think it's a selling point for us in the HVAC industry. In this chart on the left, you see MERV 13 filters in purple capture additional smaller particles than the MERV 6 and MERV 8 that we're used to in the past, including bacteria and viruses. I think we can sell that to our clients, right? Hey, with this HVAC retrofit, I'm gonna clean your air with a MERV 13 filter every time your HVAC system runs. And that's going to pull a large portion of bacteria and viruses out of your indoor air. We just went through COVID, right? That's a pretty compelling sales pitch, I think, for any HVAC professional. And so that's why this made it into the code, not so much because of COVID, but because our local communities aren't meeting our PM 2.5 standards for small particulates. And that's also what MERV 13 filters pull out. This table gives best design practices for return grill sizing. And this, if designed to this table, your system does not require one of those HERS verifications, fan watt draw. So that's a nice incentive, but you'll notice it tells you the duct diameter and the total filter grill required according to the tonnage of your ducted system. And once you hit 3 tons, it's calling for 2 separate returns. I know I don't see 3-ton systems designed that way yet, but based on the building science, this is the way we should be doing it.
Okay, I think I take over here, Nick.
Yeah, this is what so many people, I think, can benefit from knowing all the different configurations possible with these heat pumps. Go ahead, Bobby.
Sure, thank you, Nick. And I know Jenna for sure is paying attention to this because she has a quick install ductless company. But ducted versus ductless. So on the left-hand side, that's a traditional system. Like I mentioned earlier, the variable capacity heat pump manufacturers, most of which make a furnace style indoor unit, or it can be mounted in this case in the garage. And then on the right hand side, you have the ductless units. So you're going to have a very common, the world's most commonly used form of air conditioning residentially in the world is going to be what's on the right hand side, which is going to be a high wall mini split. And then we also have cassette style, various cassette styles, under ceiling, which is going to be on the left, which also can be mounted on the wall. And above that, it's going to be a traditional, what I mentioned earlier, a suitcase style condensing unit. So ductless units have been what I've been doing for the last 30 years. So it's really true to my heart. So we'll see some advantages. But coming up on the next slide, we'll start with ducted units. Rick Chitwood, if you're close to his area, he's from Shasta, California. He's really a kind of the Jedi of code. He's a code legend, credited for a lot of advancements in Title 24. Also credited for the variable capacity heat pump credit, ducts and conditioned space, fan watt draw. There's just a whole long list. So this is Rick Chitwood's top 10 advantages. First, we'll start with the high AHR equipment performance ratings. We are now into SEER 2, but all of the ducted units from various manufacturers have high performance rating for SEER 2 as well as EER. Next, this can be a little tricky, but ducts and air handlers in conditioned space. Now, you will either have to drop the ceiling in your closet or put this somewhere inside under a stairwell, or you'll have to have a high performance attic to be to get that credit. So if you can do one of those 3 things, you're in good shape there. Extremely high comfort levels. So if you're not familiar with this type of equipment, this as well as the ductless units have a linear expansion valve. So whatever your set point is going to be the exact amount of refrigerants delivered to that fan coil to meet that set point. So we can get extremely high comfort levels. One thing you can do with variable capacity heat pumps, which you can't do with a traditional unit, is they have what's called a dry mode, where we flood the fan coil. We open the expansion valve, rush in refrigerant, and then all of a sudden you're just wringing out the air. So much more options, including humidity and higher comfort level. Exceptional air filtration. We just mentioned about the MERV 13, the small particulate removal. And as you can see by Rick, it's pretty conventional as far as the fan coil goes. It's not an A coil, but very conventional looking. And you could see by, as compared to Rick's face, it's only about 9 inches in height. Back to the condensing unit, very low operating cost because of the inverter. We are not overshooting what's matching the load. We are just trying to get exactly where the load is and stay there, and low maintenance cost and built-in fault detection. So for instance, with this ducted unit in California, in a lot of cases, you're going to have a secondary drain pan. We can put a sensor in the drain pan, and it will knock down the unit in case it floods. So the unit will turn off. So a lot of built-in detection with these advanced units. Next, Nick.
I gotta add one comment on the energy code.
Okay.
There's been a lot of discussion among energy consultants and people working with the energy code on high performance attics, and do duct systems in high performance attics can they be considered conditioned space, especially when those attics are unvented? And the energy code is clear. You need to consider unvented attics, high performance attics are not conditioned spaces. Okay.
Oh,
So there's no credit for ducts in conditioned space if your ducts are in a high performance attic. There's also no credit for ducts in conditioned space if they're in an unvented attic even. The only way you get that credit is if, as you said in the beginning, you've got everything on in a drop ceiling, or you've built a conditioned box around your air handling unit up in the attic and insulated it.
yeah. So you're building a doghouse basically around that's kind of what I was trying to, I didn't mention that, but yes. So it's part of your conditioned space.
Okay, yeah, and one more thing to add, ductless systems avoid duct leakage entirely, so they're even better than these ducted systems. But it seems like once you get past what, 3 indoor units, the economics are a little better of a ducted system than installing ductless systems. Would you say that's kind of where the break is for you, Bobby?
Yeah, you know what would I see most on the, I mean, in the chat, they mentioned multi-zones. What I see most is a ducted unit handling the bigger spaces. And then, so there's always like, it seems to be a combination of a duct, one ducted unit perhaps, and a couple ductless units all combined together. So yeah, I see most multi-zones are up to about 5 air handlers. They do make them up to 9, but I'd say 5 is pretty much more traditional. So
Okay, let us know if you have questions on that.
okay, yeah, and just move it. Yep. Okay, so I like this slide here. So like we've been mentioning, no more 13 because there's no ductwork on the ductless systems. Variable capacity heat pump credit, Title 24, especially with these ductless units, you really don't have much to worry about. You know, there's no ductwork, there's no more 13, there's no HERS. So a lot of benefits with going ductless systems. Zone control for comfort and set points. We mentioned earlier, very easy installation, about the diameter of a tennis ball. And you can see that in this case, it's covered in white. We have our indoor units, we have your outdoor unit. And I do want to mention, I had an application down in Seal Beach, California, which a place called Leisure World. And Edison is the energy provider. There was radiant heat in the walls. It took hours for each individual unit to heat up. So Edison was a part of changing all that out. And approximately there was 3,000 units in this retirement community. And Nick mentioned earlier, we just got through COVID, and you know, we don't have a common return. Once you have these units inside a dwelling, basically you're in your own compartment. You're not sharing your return and supply with everybody in the building. And as the senior living homes were getting really, you know, COVID was just took a huge toll on senior living. This particular application I was paying very close attention to, and I didn't see anything coming out of there as far as COVID. I mean, I was watching it, but again, with having your own fan coil and not sharing a return with anybody can be a huge advantage of as far as like sharing the same return and having the same amount of air coming from the return into your space. So another added point, again, one thing with this unit, because there's no return air duct, there's very little mold growth, you will have to clean the units. But most importantly, I think for ductless units, to me, is there's no capacity loss. Nick mentioned earlier about 30% duct loss. There's additional capacity loss from going from the fan coil to the unit. Here, whatever you're designed at, that's what you're delivering. So you're getting maximum energy savings with ductless units. So that being said, we're going to go to the new ratings, Nick. Okay, so if we could take a look here, I think I'm not going to spend a whole lot of time, but most of you probably know we are going from SEER to SEER 2. So a little bit more stringent. For instance, an example is if it was 15 SEER, it's going to go to 14.7 SEER 2. But all the manufacturers has changed over. Every manufacturer selling in the US should be adhering to SEER 2. So if you have any questions, you're going to want to go ahead and talk to your distributor about the equipment they're selling in regards to the Department of Energy's increase.
It always like ends up flopping down.
Did you get that one, Nick?
I don't think it was a question, was it?
Yeah, I didn't know. Won't even go all the way.
Over.
It's just like,
Covered.
yeah.
There you
Yeah,
go.
just background
Oh, no.
noise.
And the other side pops off.
Okay.
Yeah.
All right.
But there was a question in chat, Bobby, about rooftop heat pumps. It's important to distinguish between those kind of standard variety heat pumps and the variable capacity heat pumps we're more focusing on. Yeah.
Right. Yeah. Now I do see that the inverter compressors are making their way into rooftop units.
How about
So,
that?
yeah. So they're the Infinity type of equipment that the highest tier of rooftop they will be changing over. So we'll see more of that versus a standard scroll compressor on off.
That's great.
Yeah. So we'll be seeing those changes. Okay, so a real world modeling example, Santa Maria, 3-bedroom, 2-bath. And I think pretty much everybody said in the chat, Nick, that they are using existing ductwork. I think Javier said 100% of the time, others 75% of the time. So we're going to make this real world example. So again, Santa Maria, 3-bedroom, 2-bath. And we're going to quote like gas furnace and an AC plus ducted. And then we're also going to compare it to ductless mini split. So let's start here with a like replacement. Again, Santa Maria, 14 SEER. Using this like, Nick mentioned 30% estimated capacity loss using ducted units. Ultra low NOx furnaces are required. So I think that adder of 350 might be even more, Nick. So
Okay.
you may want to take a look at that. And the MERV 13 requirement, you will need a HERS rater. And with ductwork or using existing ductwork, certainly you'll have a potential for mold. Next is going to be a single stage, slightly better, central heat pump, 14 SEER. Again, we have our capacity loss, MERV 13 requirement, HERS rating. Because we're going to be using possibly the same ductwork or installing new ductwork, you have potential for mold. Comparable cost to gas. However, we do have up to a 24% greenhouse gas reduction when using a heat pump. Ducted mini split, 17 SEER. As you can see, the SEER is getting higher. Using a ducted mini split, though, we do have, again, capacity loss, MERV 13, HERS, mold. Overall, though, we do have excellent energy efficiency at 17 SEER, and many are higher than that. And when we're going to the higher SEER, we are getting up to a 37% reduction. And then what we have is for our performance, we have our ductless mini split. We're going to just use an average ductless mini split of 22 SEER, 10 HSPF. However, we don't have that 30% duct capacity loss. We have no MERV 13 requirement. We have no HERS ratings, and the chance for mold in your ductwork is non-existent because there's no ductwork. And best efficiency savings, and in this case, again, we're using a ductless mini split, so we're getting away from gas up to 37% greenhouse gas reduction. So those
Right,
are our
and
full examples we're going to be comparing to, Nick.
Yeah, in a minute, we'll look at how these model out in the energy code compliance software and what that suggests for operating costs of these various options.
Okay, and Nick, we were having this discussion earlier about ducted units and ductless units. This is a good example. In the top left corner, they're going to have a ducted unit. It looks like you have on the bottom where it says 69, it looks like you have some type of cassette. In the middle of the building, you have a high wall. And then on the right-hand side, you probably have another ducted unit. So do they work together? I would say in my experience, most applications are going to have a ducted and ductless unit when it comes down to multi-zone applications for mini VRF or multi-zone. So yes, the answer is yes, they absolutely can work together. So Nick, I think the next slide, we are going to run into a Slido. So I think we're going to, you want to take over from here about some questions?
And these are past answers on the reasons to go ductless. How about you guys? What reasons have you been using to get clients to go ductless appeal most to you? I know when I did my ADU, I used a ductless mini split, 2 indoor units, a single outdoor unit, a ton and a half, I think, 18,000 BTUs was enough for the whole 576 square foot unit. And we were able to vault the ceiling because we didn't need the attic for the mechanical system. Been working great. Zones, okay. Yeah, independent temperature settings. I know as my wife and I have gotten older, she prefers the bedroom a little cooler than I do. So an indoor ductless unit would allow her to do that. Whereas when we've got a central ducted system, we've got one set point for the whole house. What about the ducted systems? You saw Rick Chitwood is able to lift one himself. He lists all those examples that make him think these are a really good solution for California. How about you guys on ducted mini split systems? Okay, yeah, simpler installs in some cases, plug and play. Yeah, lower cost as a result. You just got to weigh that against the duct losses with existing systems. What about cold weather performance, Bobby? What do you have to say about that? I don't see Bobby's smiling face there. He might have dropped off. So NIA is a Northwest United States association that's analyzed cold climates and heat pumps in great detail. And this extends to the East Coast too. I mentioned before, Maine has been a hotspot of heat pump adoption since the state government there adopted some incentives. And in the olden days, heat pumps didn't work very well in cold weather. So those rumors that you hear, those old time contractors who say, oh, heat pumps don't work when it's cold out, there was some truth to that. But since then, the equipment's evolved so much that these are used in Arctic, stations. They're able to produce heat even in those extreme conditions. So they're certainly adequate for all climate zones in California, including our Sierra climate zone, which is the most heating intensive, climate zone 16. I see a lot of these being installed in mountain communities like Idlewild and Big Bear down here in Southern California, where yes, it gets cold, but they're still able to produce heat even on those cold days. And those mountain homes often have propane tanks as their source for cooking and space and water heating. And by going to heat pumps, you can completely do away with that propane tank, which is a huge plus. There's Bobby's smiling
Yeah,
face.
Nick, the internet went, I'm not really sure what happened, but we're back.
All
So,
right.
okay, it looks like you covered the cold weather performance, but we'll go ahead and take a look at this chart here. As you can see, on the left-hand side is going to be heating. So we mentioned earlier, this is a new type of heat pump. It's an inverter-driven heat pump. are variable capacity heat pumps. So in extreme weather, like on the left-hand side, if you look at 0 degrees, we're almost getting 100% capacity. What's different here is we injection flash the compressor with refrigerant so the compressor can run at extremely high rotation and extremely low temperatures and still get high performance. So that's the main difference, is that refrigerant's getting flashed into the compressor to run harder, but run smoother at the same time, and have extremely good efficiencies when it comes to heating and low temperatures. So there you're going to see an example, 0 degrees, 100%. I think we're good in California for that. And on the right-hand side, you can see, and this application is going to be about 104 outside at 100%. So a lot of these, we'll call them, there's certain high temperature rated equipment, and I can say most manufacturers have something very similar to this type of performance. Next, this is a colleague of mine that was took a reading off the high wall fan coil, and it's 28 degrees outside in Hillsboro, and you can see off the fan coil it's delivering 122 degree ambient delivered right off the fan coil to keep up. So extreme performance at extreme temperatures, and this is going to how it's going to be for any variable capacity heat pump, that you're going to have really good performance. And does bigger mean it's better? No, that's not true at all. The if you oversize, that used to be the case. When there was any question, it was always make it bigger, because if it's too small, it'll never keep up. So overcycling's a huge one. So if you oversize an application, the compressor is just going to flash on and off from high to low in a variable capacity heat pump. It's just going to be moving all the time. So cycling is not good. Higher humidity levels, because you're going to wring out the air so fast, and then it's going to come back and it's going to go high up and down. Equipment wear, you're going to be wearing out the compressor. So you're going to have definitely go back to the humidity level. You're going to have a diminished comfort. You're going to overcool or overheat, and then your noise is also going to be considerably higher if you're cycling on and off. So next slide, Nick.
Bobby, there's a question from Javier. 18 to 20 feet of line set left beside the outside condenser use. What's your advice?
There's different manufacturers. I know that I know one. I think I know what manufacturer he's talking about. That sometimes you have to coil up additional refrigerant on the mini VRF. It depends on the manufacturer. I don't like to see that. I mean, I think that it's not a great application. I mean, it should be, if you size your unit correctly and you have your distance between your outdoor and indoor unit, you shouldn't have to coil up extra refrigerant lines at the condensing unit. So it's something I don't think it's great. It's a little bit of a safety factor, but you don't have to do that.
Another question on sizing. Isn't oversize a major impediment of heat pump efficiency? Or Bobby, would you say it's a impediment of heat pump and gas furnace split system
Yeah, I mean,
efficiency?
it's just back to this last slide. I think, yeah, efficiency, you're going to overcycle. So, like if you put a 2-ton unit where a 1-ton unit should be, it's going to constantly, it's never going to find its happy spot. And that's what an inverter wants to do is, if it's sized correctly, I've seen units run at 5 amps, in 95 degree weather, because it's sized correctly. It finds its happy spot. The condensing unit ramps down, and it's much more efficient. So does it impede on the efficiency? 100%, yes. Okay, Charles, there's heat pumps available, very small units like ADUs that are, say, 200 square foot. That you'll have to take your your load calculations, and yeah, you're going to want to size it to 200 square foot, and depending on your solar exposure and your insulation, but you will want to model it to 200 square foot. And inverters can go down to 13% of their capacity, but that doesn't mean you want to oversize it. You want to get as close as you can. So there are 6,000 BTU mini splits that exist out there. So that'd probably be pretty close for sizing in your area. So you may want to take a look at that for your 200 square foot spot. Okay, so I'm going to end with this slide for my portion. Practices for sizing, rules of thumb, throw them all out. You are going to want to take a load calc for your application. Furnace sizing is not equivalent to heat pump sizing because most furnaces are oversized. So you don't want to go and match to match. You again want to do a load calculation. You're going to have increased efficiency. So with the reduced load. So we didn't mention this earlier, but we talked about duct leakage, blower door test. Insulation is always a good idea for all three. And then perform your load calcs, whether it's CalCool, RightSoft, CBEC Res, Energy Pro, all of which are great load sizing calculation software. So
yeah, and I've started using Quick Model, which is a 3D manual J load calc software package that a colleague of mine from KBEC has introduced. And did you know the energy code, for those of you in building departments, the energy code has clauses that you can request load calcs be submitted along with the plans. It's technically required. It's just not always enforced by local jurisdictions. So that's something for you building department folks to think about. Now, the last obstacle we hear sometimes is, hey, panels are too small to fit heat pumps. And the first bullet is the one that takes care of most of these situations. If the homeowner already has air conditioning, cooling, then the capacity is there for a heat pump. That same circuit will provide heating and cooling with no extra energy use needed. Well, energy use, yes, but size of circuit does not need to be upgraded if you already have air conditioning. So that's covering most climate zones in the state. If you do have an existing home that only has heating, then yes, you may need additional panel space to go to heat pump. Because as we said earlier, you'll need the circuit for the outdoor unit, and the indoor units in the variable capacity equipment are powered from the outdoor units. But when we think about our panel, I encourage you to think about our panel as a future-proof appliance for the whole house, because it's not so much the heat pump to blame for upsizing your panel as electrification of the rest of the end uses in the home, addition of electric vehicles charging in your garage, solar systems needing that. Not to mention the electricity usage appliances no one's even thought of yet. So, if you are to the point where that 80 amp panel isn't quite enough to do your heat pump increase, then that's how you talk to homeowners about it. It's not the heat pump's fault, it's the future's fault, the present's fault, if you will. And in some cases, circuit sharing devices can allow you to electrify these key end uses without upgrading the panel size. For instance, you might put your clothes dryer and your electric vehicle on the same circuit. These are two end uses that don't necessarily need to run concurrently, and a circuit sharing device will allow you to share that space in the panel between two like that. Watt Diet's a useful tool in this sense. It is a spreadsheet application available through the link, and we're going to send out the slides at the end of this through Sarah. It establishes your base load, lighting, plug load, kitchen, laundry circuits. You enter your other loads, and the power requirements from those systems and what that calculates the size panel you need. I really like this for homeowners who are running up against their electricians telling them they need a bigger panel. Well, hey, they're probably right, but here's a tool to fact check them, to put in the exact systems, and maybe your electrician was making some assumptions that weren't quite right, and you can make it work with what you have. So I encourage you to check that out. Now, no treatment of a subject is complete without thinking about your dollars and cents. So in chat, feel free to put in your perceptions right now on heat pumps versus gas furnace electric split systems. But here's what we found in that case study Bobby introduced earlier. Remember that house in Santa Maria? It was a 3-bed, 2-bath. The existing gas furnace was at its end of useful life. The like-for-like replacement came in at $8,500. There's no incentives to replace it with like-for-like. And the annual utility bill for the whole house, when we modeled that, exhaustively with some real depth and rigor of thought, came out to $45,000 of utility bills over 15 years. So let's compare that now to first a dumb heat pump, a single speed central heat pump hooked up to your existing ductwork. For a system like that, I hear from HVAC contractors all the time, about the same. Gas furnace, simple heat pump, about the same. And there's an incentive by stacking the TEC program, which is a California incentive program for heat pumps, the federal tax credits, and 3C REN's single family home energy savings program, which we'll tell you more about in a minute, almost $5,000 off that. The utility bill, slightly higher for this dumb heat pump, but total costs are about $1,000 less over 15 years because of that incentive. Now upgrade to more efficient system like a ducted mini split in the third box. Cost is about $4,000 higher for this house. Incentive about the same, but utility bills now come in under what the gas furnace would have had by $120 a year, and you're saving $2,500 over 15 years. That's a family vacation. Go up to the best-in-class equipment, ductless multi-split. Incentive in this case about the same, but the savings are boosted by almost $300 extra a year, and you're coming out again that family vacation ahead of where you would have been with like for like. So looking at first costs, we just can't make financial decisions just looking at first costs anymore. There's so much incentive money out there. Now is the time to be thinking about these upgrades to electric systems. You want to take that question, Bobby, on expected life?
Sure. Okay. Yeah. So Charles, what is the life of a heat pump? Will the manufacturer make circuit boards for these for past 10 years? So Charles, I hope you're aware that we are going through a refrigerant change. The whole country is going through a refrigerant change. And I can tell you from my manufacturer, which I represent, Carrier, are they going to make circuit boards beyond 10 years? And that is the plan. If you're anything sold through Carrier, has to have parts for at least 10 years. So has that happened all the time? Not every single time. And I spent most of my career with another manufacturer, and that was the same. But I would say if you buy your equipment from an authorized distributor in California, that most likely you're going to have parts available to you. Now, if you get equipment possibly through the internet, a name that you don't really know, you may want to check before you buy the equipment if you can get a circuit board for it, because you're pretty much dead out of water. If you can't get that board and you have the installation's going to cost probably more than the equipment, you're going to have a real problem. So definitely go with, in my opinion, go with the top tier distributors, get the top tier equipment, and do your diligence about finding out parts availability, because that would be a big one for me. I would not put in a unit that I could not get parts for.
Bobby, you want to expand on that? When's the refrigerant change go into effect?
So basically the end of this year. Now that's for 410A. Going beyond this year, we can sell indoor units for replacement. We can sell outdoor units for replacement. But as of January 1st, 2025, we are to start with the new refrigerant. I can tell you on behalf of Carrier, and I know Mitsubishi's doing the same thing, and I'm sure Trane in New York and Lennox and are they're all the new refrigerants all coming into the warehouses as we speak. So they will be fully stocked with the new 454B as far as Carrier goes, and those other refrigerants some of the other manufacturers are going with. But for residential, it'll be at the end of the year.
Thanks, Bobby, and good
Mhm.
question. That change, of course, to switch to lower global warming potential refrigerants. So if the refrigerant is released into the atmosphere, it does less to warm our climate. Here's the modeling comparison of utility costs for various options of HVAC. You can see dual fuel, electric and gas, total house utility bills in San Francisco for a typical home retrofit, $2,300 in utility costs. That's switched from gas to electric in the central heat pump case, and just slightly higher utility bills. I'd call that a push. And then savings possible with the ducted and ductless mini split, quite a bit. What is that? $300 a year with the ductless mini split. Go to climate zone 12 in the East Bay, like somewhere like Walnut Creek, and you see a similar relationship, slightly higher whole home utility bills for the central heat pump, but significant savings. What is that? $600, $650 a year for the best in class ductless mini split. That's family vacation money. That's start your own business money, get a new car money. And HVAC is where I see the biggest operating cost savings in electrification. Now let's touch briefly on incentives, and we'll let Sarah tie things up with a quick conclusion from 3C Ren. We've never had money like this available to encourage adoption of these energy efficient technologies, not for insulation, not even for solar back in the day. So now is the time, if you're in this business or if you're a homeowner, to get on board. Energy Smart Homes offers a whole home incentive for new homes starting at $3,000. And the retrofit incentives, look at that for heat pump water heaters, $3,100 through the tech program, $1,000 for HVAC heat pumps like we're talking about here today. And the Energy Smart Homes retrofit incentives are down a little from last year, but $4,250 for a whole home electric retrofit. And these stack, as Sarah mentioned. So it used to be, boy, if you're taking advantage of this program, you can't take advantage of it through here. Not today. You can stack federal on top of state, on top of local incentives, even multiple state incentives on top of each other. And pretty soon that capital stack can be 10 grand or more. And 3C Ren has a really generous program with savings up to $3,000 possible for all customers on HVAC and water heating electrification. And if you're in one of those hard to reach low income populations, those savings are more than tripled, up to like $10,000, Sarah was telling me. So check out Switches On, which has a database of incentives available in your local jurisdiction, as well as these various programs. Now's the time. And then the federal government got in on this too. There's tax credits extended just like they were for solar systems now to heat pumps and heat pump water heaters. I just submitted my taxes for last year and got $2,000 off for electrifying my heat pump. And then programs coming like the HERA program I'm most excited about, It's for homeowners with incomes less than 80% of area median income, with point of sale rebates on heat pumps, heat pump water heaters, etc., up to $14,000 per home. So hopefully you have a few takeaways from today, maybe some lingering questions on heat pumps. If so, drop them in the chat. Sarah, you want to talk about what you just dropped in?
Yeah, definitely. So I linked 2 of our flyers from our home energy savings program. Each one is for our stackability of our program with other incentives that Nick mentioned. There's the water heating version and then the heating and cooling version. And with our home energy savings program as well, we also have a concierge service. So if there's questions, you can reach out specifically to a person and kind of get those questions answered. So the program definitely is there to encourage and help enroll contractors as well as residents to make these improvements.
I love those programs. So hopefully you come away understanding the state's heading towards heat pumps, and there's significant value for businesses to get on board. We talked a little bit about how they work, but mostly about the economics and key installation hurdles, including what to do with existing ductwork, why MERV 13 filtration is required, and how to sell it to your customers, ductless versus ductless configurations, cold weather, sizing, electrical panel upgrades. It was a lot to fit into an hour and a half. I hope we were largely successful, but what questions do you have lingering? We'll want to hear them in our last few minutes, and then we'll hand it over to Sarah to do a quick conclusion from 3C RAM. Bobby, anything I'd missed?
No, I'm just looking over some of the questions. We did talk about the low GWP refrigerant and the timelines. Commercial is going to be likely a year after, so residential will be coming first, but I think we got to most of it. Yeah.
Yeah,
All right.
and yeah, no, that's perfect, Nick. I was just going to say I can run through my closing slides and give folks a chance to maybe think of some questions. I am going to go ahead and launch our poll. This is just our general course poll. It just helps gauge course content and ensure that we're offering the courses that benefit you all, the audience. We have our Energy Code Coach service available for Title 24, Part 6, Part 11 questions. We have our online web form, which is the easiest way to get your questions in. The question goes directly to our code coach, or you can call the hotline and you'll get me, and then I'll take your question and then I send that on to the code coach. And then for the next slide, just a recap, we have continuing education learning units available, both AIA and ICC. I can submit those on your behalf. If you registered and entered your numbers in, I already have that. But if you need to send me your numbers, go ahead and send me an email. My email is there on the screen. And then we have our slides, and the recording will be going out to your inbox. And then I just have a list of upcoming courses kind of through mid-May. Our regional forum is going to be May 15th. It's a virtual forum, and it's going to be all about the past, present, and future of HERS raters. We'll also have CalCert and Cheers on. We'll have HERS raters participating on the panel. So that one should be a really great course. Yeah, so with that, I will leave it open for questions. We have about 5 minutes left.
Nothing yet. Anyone want to unmute?
This is Charlie. I just wanted to thank you guys for your time today.
Hey, thank you for attending, Charles. We appreciate you coming to our presentation, and hopefully you learned a little bit more about heat pumps.
Yeah, appreciate it.
I mentioned in the chat there was a kind of a town hall in Sacramento with the California Energy Commission, and at the time Commissioner McAllister, with most of the major manufacturers, including Carrier. And summary of the whole conversation was, can you provide 6 million heat pumps to be installed by 2030? And Carrier, Trane, Lennox, the big guys, Mitsubishi, Daikin, yes, we can deliver 6 million heat pumps. So it's coming. We're ahead of the game talking about it now, but it's going to come in a big way. And the state has committed to the 6 million heat pumps. The manufacturer has committed to providing the 6 million heat pumps. So this is it's going to come. And Nick's chart that we had, we're going to try to update it because, especially for California, that bar chart's going to go straight up next time we talk.
I had a question. This is Javier.
Hi, Javier.
The condensation coming out of the inside units, could that be, I believe there's a line there, and does that go straight to the plumbing, or can that be exhausted just to the outside like they used to do in the back, on the regular units?
Yeah, that's going to be dependent on your local jurisdiction. I'd love to see it go into a planter box myself, so you could reclaim the water. But most of the time, the applications I've been seeing is, yes, it's going into the plumbing.
All right. Thank you.
Most of the cassette units and the ducted units on the smaller size, that being under 3 tons, will have a built-in condensate lift, which is already installed in the unit. And what will happen is roughly 20 inches, it will pump upward, and then you have to vertically feed out. The high walls are the most challenging to get the condensate out because typically they're on a wall and you're not up in an attic. So you need to get that either out and vertically drain down and catch a drain somewhere, or you have to use a pump, which I would not recommend because you have an extremely quiet indoor unit. And then when the reservoir fills, it pumps out. So not a good idea if you can get away from using a condensate pump on a high wall.
So would you recommend installing the units when the framing's being done? And cover them up, tape them up, and wait until the drywall's back on? Because how do you gonna tear up the drywall to get your...
Yeah. So in this application here, if this was a new application, when the studs are up, you would just run your pipes, and then you'd come back after the drywall's installed and then just hang the unit.
So as a retrofit,
really both. You get the pipe work done first when all the framing's happening. That would be.
Then what are you gonna do with the hole that you have there for the drywall?
yeah, so as a retrofit, you either pull that piece of drywall off and run the drain down through the wall, or you punch out next to the refrigerant lines and you run that down the wall to the exterior landscaping. That's what I'm seeing in my neighborhood. A lot of these outdoor units up on racks attached to the wall where there's not room down on the ground, and just draining out to landscaping.
Or Nick, we're seeing a lot of, like, if there's multiple high walls on the same, let's say the second story, they will all come to a home run together, and then they'll pump all the units out at one time.
I see.
We've also seen like in this application where it just runs along the refrigerant line, and they'll put a outdoor condensate pump if they need to get it somewhere else.
Right. Okay.
Like, let's say that's a deck and you can't have water pouring onto your deck. You need to get it up into plumbing. So you come out, hit a condensate pump, and then come back in. And those kind of, let's say, pumps can pump 60 feet. So typically you can find somewhere to connect the drain to.
Got it.
All right, well, we are at time. So if there are any other questions, feel free to let us know. But with that, I will end our course here. And thank you again to Nick and Bobby for a great presentation. And thank you all for joining us today.
Yeah, and thank you
Thanks,
for the kind reporting. It looks good and excellent. So thank you.
Thanks, Bobby.
Thank
Always
you.
enjoy
Bye.
it.
All right, thank you guys.
Thanks, everyone.